Okay, hello everyone. Good morning. Let's get started. So, this course is Applied Mechanics Statics, and today is Introduction. So, today we'll talk about teaching team introduction and include project presentation, and then we'll talk about the syllabus and lecture one for week one. Okay. So, to introduce myself, I'm Professor Shinae Jang from Civil and Environmental Engineering. And here's my email, and the email is the preferred way to communicate with me. And then this is my office, and office hours Wednesday 3:30 to 4:30. Okay, so and then a little more about myself. So I was born in South Korea and then went to United States for PhD study to UIUC, and then I joined UConn in 2010. And I'm currently serving as director of undergraduate studies in civil engineering department as well. So I have my husband and a son, elementary school. And then my hobby is cooking Korean food and then playing musical instruments. Okay, so that's me. And then we have two graduate teaching assistant today. So I like to invite Billy and Rahul. Can you come up? Yeah.
I'm Billy, fourth year PhD student in structural engineering, and my hobby is tennis.
I'm Rahul, and this is my first semester as a master's degree in structural engineering. I did my undergrad from Idaho State University, worked for a couple of years as a structural engineer in Utah, and now I'm starting back my school as a master's student. Hope you'll enjoy the class.
Thank you. So thank you for introducing yourself. And then Billy and Rahul will teach your discussion section on Thursday. So you will see them on Thursday in the classroom. Okay. Yep. Thank you. And we have undergraduate teaching assistant as well, Jeff Lim, and he's environmental engineering and also biomedical engineering student, and he has conflict today, but he cannot join today, but hopefully next week he will introduce us himself, and then he will hold office hour on Friday, every Friday between 4 to 6 p.m. In Castleman 205. So please make use of this time, and also my office hour on Wednesdays. Okay, and then your turn to introduce is during this week's discussion section with small group. Okay. Okay. Then now I like to introduce the Include project, because this course is part of Include project, and then maybe some of you are wondering what is that. Let's see. Yep. So this is the video. And then Connie is program director of the project. So I share this video with you.
Hello. If you're watching this presentation, that means that you're enrolled in an I-course. I-courses are part of the Include program, which is a CEE department initiative aimed at building an inclusive environment for all kinds of learners. Over the next few minutes, I'm going to share a little bit about the key aspects of the Include program, a little bit about neurodiversity or cognitive diversity, which is the particular focus of the Include program, and finally some of the main features of I-courses in the Department of Civil and Environmental Engineering. The Include program is led by the CEE department head. It's supported by a generous $2 million grant from the National Science Foundation, and on a large scale, the project is all about encouraging innovation in engineering by welcoming and cultivating the strengths of neurodiverse students. We believe that many of the changes we're making, especially the changes we're making in our I-courses, can be beneficial to all students, even those who don't identify as neurodiverse. The program is actively recruiting neurodiverse students, building a supportive community, transforming engineering courses, providing specialized support, and providing career preparation for the transition to the engineering workforce. The Include program is centered primarily around the idea that innovation is most likely to happen when the engineering workforce is diverse. You already know about aspects of diversity like race, ethnicity, gender, sexual orientation, and socioeconomic status. This program focuses on neurodiversity, or cognitive variations, as a key aspect of a diverse student body. An author named Harvey Bloom wrote that neurodiversity may be every bit as crucial for the human race as biodiversity is for life in general. Who can say what form of wiring will prove best at any given moment? Include aims to make engineering more welcoming to students who've been underrepresented in engineering and whose unique wiring can open up opportunities to tackle complex engineering problems in new ways. So first, let me explain what we mean by neurodiversity and what cognitive variations fall under the neurodiversity umbrella. When the term neurodiversity was first introduced in the 1990s, it primarily referred to autism. Autistic individuals started speaking out and redefining their cognitive variations as differences rather than a disability. Since then, the term neurodiversity has expanded quite a bit. It is now a term that includes a wide variety of differently wired brains. Some examples of the cognitive variations that fall under the neurodiversity umbrella are anxiety, the autism spectrum, ADHD, depression, dyslexia, dyscalculia, dyspraxia, and other learning differences. Not all neurodiverse people have been labeled with one of these diagnoses, and not everyone wants to be. We do know that at least 10%, and quite possibly more, of our student body here at UConn are neurodiverse. For the purposes of our program, we've moved away from these labels a bit, and we're defining neurodiversity through an even more broad definition that includes variation in sociability, learning, attention, mood, and other mental functions. So you don't need to be officially diagnosed to participate in our programming or our redesigned courses. If you do want to learn more about your unique strengths and challenges, or if you think you'd like to find out about how to pursue a formal diagnosis, you can see the resource sheet that your instructor will share with you, or you can just send me an email when this presentation is over. I'm always happy to chat or connect you with resources that you can find helpful. So as a reminder, we believe that these differences and variations are very important to a diverse engineering community. While they've often been associated with challenges in the traditional education environment, it's important to note that these variations often bring strengths that can be huge assets in engineering, such as creativity and risk-taking, pattern recognition, or strong 3D visualization skills. They're invisible forms of diversity that offer benefits to society by allowing us to consider non-traditional approaches to problem solving. So why does this matter in the context of this course? Your course is what we're calling an I course. The I in I course stands for include and also reminds us of the individual differences and strengths that our students bring to the table. I courses have been redesigned with individual differences in mind so that students with all kinds of cognitive variations can personalize their learning and thrive. We're currently offering a variety of I courses. The current list of I courses includes Applied Mechanics 1, Mechanics of Materials, Soil Mechanics, Basic Structural Analysis, Operations Research in CEE, Environmental Sustainability, Fluid Mechanics, Water Quality Engineering, Environmental Engineering Chemistry, and Design of Groundwater Systems. All of these I courses have some things in common, but each instructor is encouraged to be creative and put their own spin on things. This means that not every I course will be exactly the same, but all I courses should be focused on building an inclusive learning environment that's welcoming to all students and takes a strength-based approach. In other words, instructors should encourage students to reflect on and use their strengths in their learning activities. Students should be able to personalize some course components by making choices, for example, the format of an assessment or the topic of a project. Universal design principles are implemented throughout the course, meaning that course materials and activities should be accessible, for example, by providing video captions and alt text, and also by providing multiple ways of presenting and engaging with course materials. So students have some flexibility and choice about how they learn and how they're assessed. Active learning is also encouraged as part of every I course. And finally, you'll have the opportunity to give feedback to your instructor so that you can make the course even better for the future. So at some point in the semester, you'll be contacted by our research team to provide feedback through a survey and/or interview about your experience in the course. We strongly encourage you to participate in these surveys because your feedback is going to help us understand what changes made the biggest impact and what still needs to change. This course design process is never over, so please help us make things better for the next round of students. And last, if you want to learn more about neurodiversity, you can join our online community on Instagram and Twitter. And I'd like to share our contact information. You can contact our Include program staff if you have any questions or comments about the program. Please.
Yep. So thank you. So I'll share the resource sheet for Include and Neurodiversity with my class notes and slides today on HuskyCT. Okay. So that was the introduction. Okay, then now you know this is part of Include course and the I course, so-called I course, and I like to emphasize how to succeed in my course. So there are 3 prongs: so motivation, collaboration, and professionalism, right? So this course is a required course. So I think it's interesting topic. So, but if you don't like the topic and if you think I don't like this topic, it's required, so I need to take it, then it's very difficult to focus on the topic. So try to understand, and then if you understand more, then you will like this topic. So motivation is important part, and then one prejudice of this course is maybe, yeah, this is first course of applied mechanics. This course must be easy, an easy introductory course, but that's not true. This course is not an easy course. So please use all materials and resources offered to you to get to know the topic better and then get the problem solving skill yours. And then professionalism. So you are expected to work hard and diligently to fulfill the deadlines and milestones. So try keeping the deadlines, as much as possible based on your situation. So the course policy is no late submission policy, but makeup opportunities are given for all components so that you can make up any missed component. So please do your best, and then other missed portion, then I provide some kind of alternative assignment or makeup opportunity in the end of semester or sometimes of the semester. So remember, motivation, collaboration with us teaching team to address your questions in time, right? And then professionalism, okay? So to the course logistics, so lecture time is this time, Tuesday, and then Thursday you have discussion section, small group, so less than 30 students, and then you can interact with your peers and your TA teaching us, Rahul and Billy, and then learn more in-depth problem solving. And then participation of discussion section is required, although attendance of lecture is not required at all. And the thing is, I will record all the lecture and then upload to HuskyCT. So if you miss any lectures, then you can make up. And also, I'll upload everything, including the slide and the class note what I wrote. So you can make up if you missed any lectures. And then when you see HuskyCT, then you found that there are 2 sections. And the first one is lecture section. It has learning material, syllabus and course calendar, and then weekly videos and other textbook and resources. And the discussion section site has TA's introduction, and then blank problem sheets, and then solved problem sheets after the discussion sections. So required material is textbook, right? And then now we are starting Husky Bundle program. So this course is also part of Husky Bundle. So if you click the connect link in the left menu side, then you can access your textbook. Okay. And then another required material is Clicker. So you can use iClicker repolling, and then I recommend using that because I'm typically using multiple choices, but sometimes using open-ended short answers. Then if you has remote, then you cannot join. It's not convenient to join short answer using your remote. If you're using your remote, then the channel is AC, so please use this AC. And then we'll use iClicker for discussion section as well. So install the Cloud app on your phone or bring your remote. And then I synced the HuskyCT site with iClicker. So most of you should be already registered in iClicker Cloud. But if not, look at this course on Clicker site and then enroll yourself, okay? And then for discussion section, you need to enroll yourself in the separate discussion section like HuskyCT. So find your discussion like to CE2110, 001D, or 004D, something like that, and then enroll yourself. And then the policy. So clicker point will count starting January 30 lecture. So that's the add drop deadline. And before that, all the clicker participation will be extra credit toward to participation grade to make up any missed clicker during the semester. And then check your battery level, Wi-Fi, and other technical issues. And then this is technical support. And then if you miss the clickers due to the technical error, please see me after the lecture, and then I give you the full credit for one-time basis because it's an emergency, right? So please check your technical stuff for iClicker. And then do not use your friend account, right? It's ethics, right? So be honest and then use your own clicker, okay? Okay, so I think we spent 15 minutes, so we'll have a quick stretch break. So I'll have stretch break multiple times in the lecture, so that's time to stretch. So yeah, so like stretch, right? Your hand and then your neck, right? And then you can stand up and sit down, change your seat, something like that, right? Sitting still is very bad for your health. Okay, so it looks like this. Stretch break will be quick, less than 1 minute break for stretching, okay? Okay, then going back to class logistics. So course organization. This course is flipped. So you know what it's not regular, it's flipped. What does that mean? Monday, you start your learning by self-learning. So you watch pre-recorded video on HuskyCT and then read textbook and complete pre-lecture quizzes. And then Tuesday, we meet here together on Tuesday as a large class and then review concept and then solve problem with me and then do some activities, so active learning activities. And Thursday is discussion section and it's small group and then you mainly solve problems, more problems than Tuesday. And then you will do some recitation and some activity with your small group peers. And then Friday, so by Friday is important. This assessment is weekly homework. So check your learning by solving homework and then use office hour on Friday between 4 to 6. So deadline to homework is 11:55 p.m. on Fridays. And then we offer Friday night office hours, so please use those time. And I strongly recommend start your homework on Wednesday. So not Monday, not Tuesday, but Wednesday, because you watch the video on Monday and then Tuesday, you strengthen your skill by problem solving, right? And then Wednesday is perfect time to start your homework. And then Thursday, if you have any initial question about homework, ask your TA, right? And then Friday, use TA's office hour and then complete it, okay? Okay, and then grading out of 100%, two midterm exams 40%, and then final exam 30%, quizzes 10, homework 10, and class participation is 10. So 5% is for lectures and 5% is for discussion. And what is quiz? So quiz is kind kind of McGraw-Hill Smart Book component. Is like conceptual questions. So you read the book, right, Smart Book, and then answer the quiz questions on Connect site. So yeah, so use textbook sections written in the syllabus course schedule, and then read the textbook, and then go to learning module week 1, and then click the quiz button. Where's the quiz button here? So pre-lecture quiz or quiz, same thing, right? And then the quiz was designed to complete in 15 or 20 minutes if you read the textbook. But if you are not ready, then it can take more time. So please be ready, because the number of quizzes are changing based on your choice. If you're correct, then it's marked. If you're wrong, then it will not ask you the same question, but it will ask you another question, right? So yeah, be ready. So for the full credit, you should solve quiz problem until you get correct for a different number of problems based on your confidence. So yeah, check it out. Yeah. And then homework is also on Connect site. So the link is also on HuskyCT, and each homework is 100 points. And due date is aligned with course calendar, but mostly Friday night. Not this week, but starting next week. Okay. And then you can attempt unlimited times before the due date. After due date, no, sorry. And then you can check your answer 5 times per problem. Okay. And then you can review the textbook and hints on solving using Connect. So I think that's good aspect for using Connect site. And the solutions will be available after the deadline from the Connect site. Okay. And then no extension is allowed, but the lowest score will be dropped. So you have one homework can be dropped. Okay. Any questions so far? Okay, keep going. And participation. Class participation has multiple components. So course orientation items and clicker quiz. So that's like using clicker. We'll try clicker today too. Yeah, if some of you are ready. Then it's some simple multiple choice or true false questions. And then grading is based on purely participation, not based on correctness. So participate and then get the credit. And then 1 point per lecture. So I can ask you multiple clicker questions, but as far as you participate in one question, then you will get 1 point. Okay. So based on participation and at least one problem. Okay. And then self-reflection surveys are given after each midterm to check whether you are feeling about how you're doing for this class. Okay. And then mid-semester assessment. And discussion section participations are about the attendance and participation. And then Rahul and Billy will communicate with you on Thursday. Okay. And then midterm dates are already given. And then final exam, I don't know the date, but the registrar's office will give us the date, right? And then for this semester, because IRB approval was not given to us, so we are not sure I'll provide the final project or not to replace the final exam, but typically I provide final project. So I'll communicate about the options about the final exam later, maybe after midterm 1. Okay. Okay, then you can reschedule exam, final exam through the approval from the registrar's office, but you can ask me about the rescheduling midterm exam if you have some athletic team activities or medical emergency or family emergency. And then I strongly recommend to contact CSD and get the letter if you have some need some accommodation. And then one makeup exam will be offered on Friday, April 14th. And then materials use the same range. So if you need to make up midterm 1, then the range is the same week 1 to 4. If you need to make up midterm 2, then the same thing. Okay. And then please let me know if you want to make up exam on this day by April 8th. Okay. Okay, then let's have 1 minute transition break. And then if you have Clicker Cloud installed in your smartphone, then try joining this Clicker channel for the statics course. If you have remote, then the channel is AAC. Okay, some of you are done, then I give you first question about the polling break. So which department are you from? So it's a short answer, and then I start. And then let's see. So far, mechanical engineering is majority, yeah. And then 55 students joined the channel. Okay, I'll give you 10 more seconds and then close. We have another one after. Okay, so yeah, mechanical is majority, and then we have biomedical, and then MEM, CE, EMV, right? And then check, and then multidisciplinary. Okay, yeah, MD, good. Welcome everyone. And then let's see. The second one is this: what is your strength? So I'll give you a couple minutes to think about your strength. It could be skills or your strongest trait. Anything is fine. So think about what's your strength, right? So based on this one, this result is helpful for me to design some kind of other activity, strength-based activity. So just think about and then respond to this question. Okay. Okay, I close this poll in 10 seconds. Okay, so we have 71 students responded, and then these are all great So creative, realistic, hardworking, determined, self-motivated. So very good strength, and then I'm so happy to work with you, such a great student. Okay, good. Okay. Then now we will move on to week 1 lecture. So week 1 lecture will be very simple and then almost what you already know. So week 1 is introduction, system of unit, and vector force resultant. And all the slide will be uploaded on HuskyCT, so you don't have to write down every single details, but it is recommended to write what you want to emphasize and then things like that. Okay. And then after the title page, I start with learning objective like this. So I give you what we'll learn. So we'll review 2 systems of units, and we replace multiple forces acting on a particle with a single equivalent or resultant forces for 2-dimensional exams using parallelogram law and then triangle method. Yeah, maybe some of you already know how to use vector, the rectangular component approach, but this is very important to connect this knowledge with other disciplines in engineering. So that's why we are learning that. Okay, systems of units. So kinetic units, their length, time, mass, and forces. And we know there are 2 systems. So SI units, so that's international system, and the US units, so it's using pound, feet, and yard, things like that. And then SI is kilogram, second, meter, things like that. Okay, and then conversion chart between SI unit and US unit. So that's well known, and then you can find the conversion relations very easily. And so, yep, it's very quick review, but any questions about systems of units? In this course, we will mainly use US units, okay? Okay, and then the second one, significant figure. So it's figure number. It's not picture, but it's number, significant figure, right? So it's usually appropriate to record parameters beginning with 1 with 4 digits, and then so 3 digits in all other cases, right? So how many digits we will use, and then how many significant figures are in a number, right? So that's about this significant figure. So for example, these numbers have 2 significant figures. 24, obviously only 2 numbers. 2.4, right? What about 0.24? There is 0, but this 0 is just placeholder. We don't count as significant figure, right? So it's just 2. And then 0.0024, only 2 significant figure. We don't count zeros left side of the number, but we count 0 after, so right side of the number, because it indicates the precision of the measurement. So if you're here, so 0.020, how many significant figures? 2. 2 and 0. These 2 are the significant figures. Okay? And then what about 3 significant figures? Things like this, right? So 364, it's obvious, right? And then this also 2. And then this third one, this left one doesn't count, but only 3 are counted. And then the last one, these 2 are not counted, but these 3 are counted, right? So I'll give you another one, the 4 significant figure cases, right? So this one, 4 numbers, and then here we don't count the left zeros here, so only 4 digits, right? And then 24.00, we count all 4 because 00, right side 00, indicate the precision of the measurement. Okay? So now clear quiz. So 20.45, how many significant figures? So this is short answer, so I changed to multiple answer. Multiple choice. Yep. Okay, so 73. Okay, yeah. So I close this one and then show the results. And C has the most vote, and the C is 4, right? So great job. 1, 2, 3, 4. 4 numbers, right? Great. And then the second one, what about this? How many significant figures in 0.000480? I see some smiles. It's too easy. Okay. So I show you some result here. Okay. B has the most vote and C 2 votes. Okay. And what A one. Okay. 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 Stop here. And then we don't count the left zeros, right? And then we count 4, 8, and then right 0. So 3. So 4 for this one. Okay. Great job. Now, the last learning objective, resultant. So, resultant of forces, what does it mean? So, force is a vector quantity, so it should have 3 components: magnitude, 10 pound, point of action, A, and then direction, 30 degrees from the horizontal plane, right? And then combined effect of 2 or more forces may be represented by a single resultant forces, like this. So, if we have P and Q, then the resultant force should be combination of P and Q expressed as a vector R, right? So it's vector sum of P and Q, that's R, right? Okay, and then how to find R? So resultant is equivalent to the diagonal of a parallelogram, which contains the 2 forces and adjacent legs. So parallel line here, and then connecting the starting point and end point. So that's the parallelogram method. So the first method. So it's purely graphical. So if you have 2 forces, then just form a parallelogram and then connecting the starting point, the end point. So that's a resultant force. Okay. And then the graphical method, so it's about the parallelogram method, right? And then the second method is triangle method. So we are forming a triangle with 2 forces, and then it's the first force and the second force, and then connecting the starting point and point. So this is the resultant. And then if we use the triangle method, then using the trigonometry, we can actually find the magnitude of the resultant and the direction, means the angle of the resultant. So parallelogram method is purely graphical. So you can plot the parallelogram, then that's all. So the resultant and angle indicate the angle. That's all. You don't have to calculate the angle or resultant. But the second method, triangle method, is quantitative. So using the trigonometry, you need to find the magnitude and the angle. Okay, so more about the trigonometry. So there are numerous trigonometry rules, right? But in this course, we can solve all problems with 2 laws, law of sine and law of cosines. Here's the law of sine, like this. The ratio between sine of one angle to the opposite side is the same for the other pairs, right? And then law of cosine, so one unknown side square is the other side square sum minus 2 times multiplication of 2 sides, and cosine of C is the other, so the angle between 2 sides. Okay, so we'll practice this one when we solve the problem later. But the triangle method is quantitative method, so we prefer using those methods. And then the ultimate preferred method is using rectangular components, x with cosine and sine and components, right? So that's that. Okay, so that's the first part. Typically, so my lecture will be, we'll have 2 parts. First part is recitation of what you watched in pre-lecture video, but today I didn't expect you watched anything, so it was kind of long, and then I went over the syllabus. That's why we spent about 40 minutes, right? But typically less than 20 minutes, and then we'll have 3-minute stretch break 3-minute transition break, and then spend more time in problem solving. Okay, so we'll start the problem solving. So everyone has problem sheet now. So like today, TA will provide the blank problem sheet every week so that you can work on the problem sheet with me and then improve learn how to solve the problem. Okay, today we have only one problem because of time, and also today's introduction and how to run this course. Okay, so I brought problem 2.2. So read the statement here. Two forces applied as shown to a bracket support. Bracket support, two forces, and sorry, this is blurry, but this is 800 pound, and this is 500 pound. This is 60 degrees, and this is 35 degrees. Okay. And then determine graphically the magnitude and direction of their resultant using the parallelogram law, the triangle rule. Okay. So we just talked about parallelogram law and then triangle rule, right? So we will use both of them and then find the resultant. And especially for the second one, we'll solve using trigonometry and then find out actual magnitude and then direction together. Okay. Let's see. So here, this was 800 pound. And then this is 500 pound. This is 60 degrees, and then this is 35 degree. I hope the graphic is much clearer on your problem sheet. Okay. And the first method is parallelogram law. And then I mentioned parallelogram law is purely graphical, right? So we will plot the parallelogram and then indicate the resultant, and then that's all, okay? So here, 800 pound, and then 500 pound, right? So that's the current setup. Right? And then we can plot the parallel lines like this. And then connecting the starting point and the end point like this. Right? And then this is the resultant R. And then the angle of the resultant here is alpha or theta or some kind of unknown angle, but roughly like this. Show you this one too. Okay, any questions? Yes. Okay. And then moving on to the triangle rule. So now we will form a triangle using these two forces, right? So let's see. If we start with this 800 pound, let's see, this. So I'm using exaggerated plots, okay? And then we have 500 pound. So from the endpoint, plot the 500, something like this. And then connecting the starting point and the end point, right? So this is the triangle we got using triangle method, right? And then it's the same as this triangle, right? And now we need to find the magnitude and the angle. So we need to use other information given in the problem. What's given in the problem? Angles, right? So let's use the angles. So 800 pounds is forming 60 degrees from the horizontal line. So I'll use this one as 60 degrees. And then 500 pounds is forming 35 degrees from the horizontal line. So I'll use 35 degrees like this, right? And then we need to add our target in the problem, right? So what is the target? R and alpha. So I'll add alpha here. Okay. Any questions so far? Okay, then now let's focus on this figure only. Okay, so now we have two sides, and then one side is unknown, and then we know these two angles, and then alpha is unknown. And then we have two choices, lobe sine, right, or lobe cosines. Is there any rule we can use right now with what we have? Lobe sines, ratios are the same. And then do we have all three angles? We can try to find it, right? But we don't know, right? So indeed, we need to find some more information using the angles, right? Okay, then which angle? I see 60 degrees here. Then if we plot the guideline here and then forming the right triangle here, maybe we can find this angle. Is this 90? This is 60. And then what should be this angle? 30, right? So this is 30. And then what about this angle? This is horizontal, vertical, and then this angle is 35. And then it should be 90 minus 35. So that's very quiet class. Yeah. I heard the answer. So 90 minus 55, right? So 55 degrees. So now we got one angle, 30 plus 55, so that's 85. So this angle in total is 85 degrees. And then let's keep going and then find the expression of this angle. How can we express this angle? We know this is 60 and this is alpha. So this should be 60 minus alpha, right? Although we don't know alpha, right? And then let's plot this horizontal guideline. And then what is this angle? If these two lines are parallel to each other. This, right? Alternate interior angle. So that's alpha. And then what about this angle? These two lines are parallel to each other. And then this one is 35. So inverse Z, right? Internal, alternate angle. So this is 35 degrees as well. So this angle is 35 plus alpha. This angle is 60 minus alpha. And then this is 85 degrees, right? So it's geometry. And then finding out these angles are very important skill for civil engineering and then maybe biomedical engineering as well, right? So that's why we are learning this. And then now, can we use either lobe sine or lobe cosine? Yes. I would start with lobe cosine. So what is lobe cosine? Let's see. Something like this, right? So if one side is unknown, then sum the squares of other two sides, and then minus 2AB minus cosine C is the opposite angle of C, right? So now we know 800 and 500 and R is unknown. So our C is R, right? Then two side, 800, 500. So 800 square plus 500 square, 2 times 800 and 500. So A is 800, B is 500, right? And then cosine, which angle? The opposite angle to R. What is that? The opposite angle to R? 85. Yes, I heard that. So 85, right? R, opposite angle. R, 85, right? So 85 degrees. Okay? Then now, if you happen to have calculator, please calculate R square, 800 square plus 500 square. Make sure your angle should use degrees, not radian. Okay. I have this number, 820,000 to 75 something, right? Anyone who got these numbers? 2, okay, thank you. And then, so that's R square, and we can find R by square root, right? Square root of this one, then it is 905.69. So we found the resultant magnitude, and the unit should be pound. That's good. And is that all? Are we done? No, we need to find direction, angle alpha, right? So to keep going, to find alpha, we must use lobe sine, right? Because we already used lobe cosine, and then the other equation we can use is lobe sine. So lobe sine is ratio between sine some angle to the opposite side is same for all three sides. So let me see. Okay, good. So lobe sine, and starting with sine, which angle should we start? Anyone is fine. Which one to start? Okay, 85 is 65 is alpha. Okay, 85, 85. And then the 85 is here. So the opposite angle to 85, opposite side to 85 is R. So I use R, so 905.69. Okay, and then that is same equal to sine of another angle. You can use either this angle or this angle. It has alpha in the equation, so we can solve it. So if we use this, sine 60 degree minus alpha over the opposite side is 500, right? If you want to use this angle, then you can use sine 35 plus alpha divided by 800, right? Okay, then we can solve this to find alpha. So now okay. So can you solve it? Yes, I'm sure you can, but I show you how to. So I use sine 60 minus alpha on the left-hand side, and then, right, go to 500 over 905.69 times sine 85 degree. So basically what I did is multiplying 500 to both end side. So both 500 here, 500 here, and then canceled. So this one move to the left-hand side for convenience, and then move the left-hand side to right-hand side. Okay. Okay, then here, let's calculate this. Right? So 500 times this one over 905, so 0.54996. You can use 0.55. Yeah. Okay. And then what else? The left-hand side is sign, and right-hand side is number. To find alpha, inverse sign, thanks. Right? Then this one canceled, right? And then we have 60 degree minus alpha, and then inverse sign. So let me see. So show inverse sign, the number here, and that's 33.365, right? Now this is degree, okay? And then you can find alpha. So feel free to use your calculator to find alpha. And if you find alpha, please let me know. 26.63. Thank you. Anyone else who got different number? Or same number? Okay, I have seconds, so this is good. So alpha is 6.63, and now our final answer is like this. R is 905.7, or 69 is fine, yeah, pound. And the angle here is 26.63, and the box. Okay, so for this problem, there are two forces, and then we use both parallelogram method and triangle method. And then triangle method, the tricky part is finding out these three angles by geometry. And then after that is more straightforward. We use law of cosine here, find the magnitude, and law of sines to find the alpha. And then the force itself is vector. So you need to indicate the magnitude and the direction if the point of action is already given. Okay, so that's the problem solving. And any questions? Yes. Great question about the significant figures. So we got this 905.69, so 5 numbers. Should we use only 4 significant digits or 3 significant digits, something like that? So for this kind of problem, you can use maybe 4 significant. 4 is kind of, yeah, good number, significant figures you can use. But if it is not asked to use any kind of significant figures in the problem, you can use any numbers. So especially for exam, if I don't ask any specific significant figures, it's your freedom to use any significant figures. Okay. Other questions? Okay, if you have individual questions or permission number, please come up and have a nice day. I'll see you next week.